In this video for section 11.7, we're going to be doing some conversions from rectangular to cylindrical and cylindrical to rectangular. Our first two items here on this page are points in space, and we want to convert those points in space either from rectangular to cylindrical or cylindrical to rectangular. The examples that follow are surfaces in space, either planes or quadric surface or surfaces or cylindrical surfaces, and we want to convert those into the other system. I'd like you to try some of these on your own using the conversion equations that are provided in this chapter, and you can pause the video, come back and see how I work out the solutions to these problems. Our first example is converting the rectangular point to a cylindrical point using the cylindrical coordinate system. Let's go ahead and identify the parts of the rectangular coordinates are x, comma, y, comma, z. So x is equal to 2 radical 2, y is equal to negative 2 radical 2, and z is equal to 4. Now these are the conversion equations so that we can convert from the rectangular to cylindrical. And cylindrical, the coordinates are r, theta, and z. To find r, we can use this conversion equation. R squared equals x squared plus y squared, where x is equal to 2 radical 2, that quantity squared, plus y, which is equal to negative 2 radical 2, quantity squared. And when we simplify that, we get r squared is equal to 2 squared to 2 squared is 4 times 2 is 8. 8 plus 8 is 16. So if r squared equals 16, then r would equal 4. To find the angle theta, we use the second conversion equation where you have tangent theta is equal to the y, which is negative 2 radical 2, over the x 2 radical 2, and we get negative 1 when we simplify that. So the tangent of theta is equal to negative 1. To find the angle that corresponds to the tangent theta equals negative 1, you can find the arctan of negative 1 or inverse tangent of negative 1 and find that the angle theta is equal to negative pi over 4. And then the last conversion equation is z. Z simply converts to z, so z is going to be the same thing in rectangular and cylindrical. So our point located in the cylindrical coordinate system would have a radius of 4, an angle of negative pi over 4, and a z of 4. Now it is a good idea to sketch these points in space and make sure that this angle theta is the correct angle, because when you do the inverse tangent, it gives you the reference angle. Now let's do the example on the bottom, convert from cylindrical to rectangular. So we're given here the points using r, theta, and z, and we want to convert to the points x, comma, y, comma, z. And here are some of the conversion equations we can use for that. X is equal to r cosine theta, which is going to be 4 times the cosine of pi over 2, which would be an x. Y is equal to r sine theta, so that's going to be 4 times the sine of pi over 2. And z is going to equal z, so z is going to equal negative 2. When we simplify this, x is equal to 4 times the cosine of pi over 2, and cosine of pi over 2 is 0, so x is going to equal 0. Y is equal to 4 sine pi over 2. Sine pi over 2 is 1, so y is going to equal 4. And then z is going to equal negative 2. So the coordinates of this point using rectangular is going to be your x, y, z, 0, 4, negative 2. All right, on this one, we want to convert these surfaces in one system to the other system. The first is the rectangular surface x equals 4. That's a plane in space. We want to convert that to the cylindrical coordinate system. The conversion equation we can use is the first one, x equals r cosine theta. So we're going to have x equals r cosine theta. Let me go back here. And replace the x with 4. So 4 is equal to r cosine theta. And oftentimes in cylindrical coordinate systems, the equation is represented as r equals something in terms of c and theta. So if we solve this equation for r, we can divide both sides of this by cosine theta. And the right side will divide out, will simplify. So we get the equation r is equal to 4 over cosine theta. And another way to write that would be r is equal to the reciprocal of cosine theta is secant theta. So for secant theta would represent the same plane surface using a cylindrical coordinate system as you would use x equals 4 using the rectangular system. All right, let's go ahead and look at the next example. This we have the rectangular surface z equals x squared plus y squared minus 2. That's an elliptic paraboloid if you refer back to the quadric surfaces. We want to express this using cylindrical coordinate system. So what we're going to do is we're going to replace this x squared plus y squared with what x squared plus y squared is equal to. So our equation becomes z, which is equal to, we're going to replace the x squared plus y squared with r squared minus 2. And that's basically it. Our surface of the elliptic paraboloid in space using cylindrical coordinates is z equals r squared minus 2. Notice it is a little bit simpler than our z equals x squared plus y squared minus 2 using the rectangular system. Okay, for this example, we want to convert the rectangular system, x squared plus y squared equals 8x. This is a surface in space. We want to convert it to the cylindrical coordinate system. By using the conversion equations, we get, by the way, this ends up being a cylinder when you sketch it in 3D. We're going to replace the x squared plus y squared with what it's equal to. X squared plus y squared is equal to r squared. So we can write this as r squared equals 8x. And we can replace x with what that is equal to when we convert. So that we can write this as 8r cosine theta. Now it is often nice to be able to write this cylindrical surface using r equals something in terms of theta. Now both sides of this equation has an r. We can divide both sides by r without losing the surface to get r equals 8 cosine theta. So that would be our converted equation. The cylinder using rectangular is expressed as x squared plus y squared equals 8x. And the cylinder using cylindrical coordinates, where we can express it as r equals 8 cosine theta. Now this middle example, I don't have a lot of space here to do the conversion, but the cylindrical equation z equals 2 is the plane in space that's parallel to the xy plane. The conversion equation here is simply z equals z. So if we are converting and we're just using z equals z, then z equals 2 in cylindrical is exactly the same thing as z equals 2 using rectangular. Now the last one that we'll do when in terms of rectangular and cylindrical coordinate systems is the following. We have r equals 2 cosine theta. Now that does end up looking a lot like the first one on this slide. r equals 8 cosine theta. So to get back to the rectangular system, what we're going to do is multiply both sides of this equation by r. Whenever you do the left, you want to do the same thing to the right. So we get the equation r squared is equal to 2r cosine theta. Now we can do the conversion. We can replace r squared with what it's equal to in rectangular. R squared is equal to x squared plus y squared. And 2r cosine theta, r cosine theta can be converted to 2x. So we have our rectangular equation that also represents that cylinder x squared plus y squared is equal to 2x.